we're going to do one more of these, and maybe two. The next one, I will do the next one all the way. All right, this is on you. I want you to go ahead and start generating some of this series, and I want you to keep it in two terms, not like this way, but like this way, where we have something minus something plus something minus something. Does it look like it's working? Is it telescoping?
So far it does.
Good. Are you getting 1/2 minus 1/4? Was that the first one?
Mm-hmm.
And then 1/4 minus 1/8. And then 1/8 minus 1/16. And I got the idea. I'm stopping there. So I can see that all the middles are going to cross out. And at the very end, we're going to have this term, which won't cross out, and the first term, which won't cross out. So that's the summation. When we're done, everything's crossed out except the 1/2 and the last term, which is right here. Minus 1/2 to the n plus 1. So that's if we take a partial sum and stop it at n. But we want to go for infinity. How do we do that? We take the limit of this 1/2 minus 1/2 to the n plus 1. So, Gianni, what happens to that limit when you take it?
It goes to 1/2.
It does, because this zeroes out, and we just get 1/2. All right, so they're not so bad. So, there are some sneaky telescoping series that I want to go over, and I'll assign you those 5, and that might be all we have time for. I like to do geometric, but we'll see what time it is. Do I have some space, Jonathan?
The one in the box you can erase up to there.
What, the one what?
The ones in
This?
the box, yeah.
Okay. All right, good, just what I need. All right, still telescoping series. Can you tell us telescoping series when you look at it? Notice it's two fractions. There's a minus. If there's not a minus, nothing's going to drop out. So there's going to be a minus between the two. Usually the numerators are the same. They could be a 3 or a 4, but they're going to be the same. And then some value here that's related, just some value here. They're going to be different, of course, but there's some relationship. They look similar. So I want you to kind of take a picture of those and see what it looks like. Does this one meet that picture? There's a 2 terms, a minus sign, there's a 1 on the top, and then n and n plus 1 are closely related. There's a minus. So it might surprise you when I tell you this one's telescoping, because it doesn't fit the picture. So let me show you. We have to kind of force feed it into the picture. All right, write this one down. Finally, something else a little new today. All right. Doesn't look telescoping, does it? The way we've seen it. It's not even 2 terms, it's 1 term. So how can anything drop out? So I don't even see a minus sign up there. So believe it or not, you all right?
No.
How did you know?
No, it's the worst nightmare coming
It actually
true.
might be like that.
partial
Is this where you have to take them like, because it's quadratic too.
It's not. This one's not.
Wait, I thought it was
Change.
quadratic.
You have to factor
This
it.
is what
If
they
the
do
factors are quadratic. So Aaron, factor this for
Oh,
me.
I'm so bad at factoring.
You can do
Okay,
this.
it'll be
One
n
plus 2.
plus, no, minus.
I meant 1 plus 2, 1.
What?
I meant 1 plus 2, 1.
And then 2, and then 1.
I keep saying 1 instead of n.
All right, so first thing you do,
There's no.
if the bottom is factorable, go ahead and factor it, and then suspect partial fractions. So we're going to put a over n plus 1. I don't think they gave you any ones that had quadratic quadratic factors. So I think they were kind, so. All right, what do? I multiply through by n plus 1, n plus 2. So, Gianni, tell me what you get when you multiply through by that.
You get 3 is equal to a times n plus 2 plus b times n times 1, n plus 1.
Right, all right, so Morgan, what do you want to let n equal?
Let's have it equal -2.
All right, then we get 3 equals b times -1. So b equals -3. You agree? All right, and what else, Morgan? N equals what?
-1.
All right, then we get 3 equals 3a? Oh, yeah, 3a. No. You can do this, 1a, so right?
Yeah.
A equals 1/3? No, A equals 3, oh my gosh. I'm the one who must hate partial fractions. No, I'm fine with them. So A equals 3 and B equals -3. Alright, so I'm gonna rewrite this. And it's gonna be the summation. This n equals 1 to infinity of A, which was 3, over n plus 1, minus 3, over n plus 2. Now, I prefer to get the 3's out of there because they're going to create fractions when I generate stuff that, I mean, there's going to be fractions, but they're less tedious fractions. So what could I do with the 3? Any ideas, Morgan, what I could do with the 3?
Take it out.
Yeah, it can cross the summation sign because it has no n in it. And the summation deals with things with n in it. So I'm going to take it out in front. It's just a suggestion. You don't have to. It will work, but you'll have a little bit more cumbersome numbers to work with. All right. Aaron, will you start generating some of these values, putting in a 1?
1/2
Gonna erase pretty
minus
much
1/3.
everything.
Oh, really? You up to here?
Not there, just,
Okay, all
but
right.
I finished the 1/2.
Okay.
That's,
All right, so I can get this.
Miss
Right,
Val, I have
right.
a question.
Mm-hmm.
Do you even have to technically do all the numbers out if you realize that it's the summation thing? I mean the telescope thing?
Yeah, and here says sure that it is, but there are some of these that you'll meet today where you're gonna have more than the first number repeating. So you're gonna have to put it out just to make sure. I'll tell you that in a minute. Erin, what do you get when you put in a 1?
1/2 minus 1/3. Plus 1/3 minus 1/4.
Alright. I get it. Alright, that. So all these are gone. So what remains then, Aaron, we've got the 3 out here. We're going to take the limit as n approaches infinity of 1/2 and minus 1 over n plus 2. And so, Aaron, what's the final answer there?
It would be 1/2 times 3, so 3/2.
Right. Now, the question is, can we just skip all this? And unfortunately, there's some in our homework that I'll probably just release you to work on. And then if you get success, I'll draw you back and we'll do geometric series. So these, you'll notice when you do your homework, sometimes it'll be something like this, Morgan. It'll be 1/2 minus 1/8 plus 1/3 minus 1/4, and nothing drops out right away. But then down here, some of these up here will drop out, and down here the rest of them. So you'll see eventually they'll drop out, but maybe the first 2 won't. So you're going to have to grab those, so it's not quite as robotic as I've shown you. All right, so let's try some of these. And that'll be your assignment and your classwork. So let's see. Let's do 5 of them. 9.2b, we're going to be on 9.2 for a while. And we'll do numbers 29 to 32. 32 has a different direction, but all I want is the sum, not all the hoostrap that they asked for on 32. And number 41. So what was that, 29, 30, 31, 32, and 41 are all telescoping. They're all telescoping series, and I'll be here to help you if you hit any bumps in the road.
Oh, did we take notes on any G and F?
No, we didn't get to that.
Okay.
Miss Powell, I'm gonna turn off the video now.
All right, Brendan, I hope it's been good. We'll see you on Monday. Bye.